Welcome back. This is the second lesson recording for IM1, September 25th, 2020. So where we left off was that we've filled in our notes for the product rule and the quotient rule. Now we are going to go into the power rule and the distributive exponent rule. Okay, these are all the things that we've actually done before, but this will summarize. Okay, so let's start with this x squared all raised to the power of 3. Okay, so this number 3 tells me that whatever is in the parentheses is being multiplied to itself 3 times. And what this tells me, what's inside the parentheses happens to be x squared. So then I can rewrite this as x squared is just x times x times x times x times x times x. Or really this is just x being multiplied to itself 6 times. Okay, but let's think about this. Is there another way to think about this? X squared all raised to the power of 3 means x squared is being multiplied 3 more times. So we can think of this as x to the power of x squared was multiplied to itself 3 times. So it's just 2 times 3. So which is same as 2 times 3 is 6. That's how the 6 came about. So in a more generalized form, this will be x to the power of m all raised to the power of n. So now we are using variables to signify, this can be any number. This can be written as x to the power of m times n. Okay? And if we were to do some examples, we don't have to expand this out anymore. It would be kind of tedious to multiply m to the 7 times, m times 7 times, and then do that twice. So instead, we can rewrite this as m to the power of 7 times 2, which is same as m to the power of 14. What about 3 squared all raised to the power of 4? That's same as 3 squared. And then we can multiply 2 times 4 here, just doing the exponents separately. 3 times 2 times 4 is 8. And then finally z to the c squared all raised to the power of 5 is same as z squared 2 to the power times 5, which is same as z times to the power of 10. Okay, now let's go on to the next part. This is the distributive exponent rule. Now this time you have x and y being multiplied. What's inside the parenthesis? Multiplication of 2 different things all raised to the power of 3. We know that this is just whatever is in the parenthesis multiplied 3 times. That's what this 3 tells me. And what's in the parenthesis is really just x times y and x times y and x times y, and in between, of course, it's multiplication. Okay, so if we collect all the x's together, we have x being multiplied to itself 3 times and y being multiplied to itself 3 times as well. It's almost as if this 3 is distributed or passed out to both x and y, and that's how you get this x to the power of 3 and y to the power of 3. So I can generalize this by filling this side out. So you can say x to the power times y. If you have x times y all raised to the power of m, this is same as x to the power of m times y to the power of m. Okay, let's do the other problem. X over y. This time, instead of multiply, you are dividing. So this, whatever is in the parentheses, is multiplied to itself 4 times. That's what this 4 tells me. And what's inside the parenthesis happens to be x over y. And when you're multiplying fractions, we always multiply across. So x is as a numerator, x is being multiplied to itself 4 times here. And then denominator, the bottom number of the fraction, y is being multiplied 4 times here as well. And it's almost as if this 4 exponent 4 is being distributed to x as well as to y as a form of exponent. So we can summarize this in the generalized form and say that if you have x divided by y, all raised to the power of certain number n, then this is same as x to the power of n and y to the power of over y to the power of n. Almost as if this n was distributed to both numerator and denominator, and likewise here the m was distributed to both x and y here. So that's why it is called distributive exponent rule. And then let's do some examples. You can pause the video and try to do these examples yourself. Okay, let's go through it together. This 3 is being distributed to both 2 and a, because 2a just means 2 and a are being multiplied. So that just becomes 2 to the power of 3 multiplied by a to the power of 3. What is 2 to the power of 3? 2 to the power of 3 is just 2 times 2 times 2. That is 8. And a to the power of 3 cannot be simplified anymore. So it's going to be 8a to the power of 3. What about this? 6x squared all raised to the power of 2. Okay? Again, the distributed exponent rule tells me that it's like this 2 is being applied to the first term that's being multiplied and then second term multiplied. So that just becomes 6 squared multiplied by x to the power of 3 all squared. But now we're going to use the power rule that we just covered here. Okay, when something is raised to the power of m and then raised to the power of n, then we just need to multiply this out, right? So that just becomes 6 squared is what? 6 squared, 6 times 6 is 36, and x to the power of 3 times to the power of 2 is going to be same as x to the power of 3 times 2, which is same as 36 times x to the power of 6. That's my final answer. Let's do the bottom problems. Okay, so this is saying the exponents is being applied to the numerator and denominator. So that just becomes m to the power of 4 over 3 to the power of 4. And m to the power of 4 is just m to the power of 4. We can't simplify it anymore. 3 to the power of 4 just means 3 times 3 times 3 times 3, which is 81. And that's my answer. And then lastly, this one is 3 needs to be applied to both 2x as well as to the bottom part, 3y squared. So that's like saying 2x has to be raised to the power of 3 and 3y squared has to be raised to the power of 3. Okay, and I know that again from the distributive property, I need to apply these two separately, as well as this needs to be applied to 3 and y squared separately. So that just becomes 2 to the power of 3 multiplied by x to the power of 3 divided by 3 raised to the power of 3 and y squared raised to the power of 3. And this simplifies to 2 to the power of 3 is 2 times 2 times 2, which is 8x cubed. Denominator 3 to the power of 3 is 3 times 3 times 3, which is 27. And y squared all raised to the power of 3. Again, we're going to use the power rule again. And that just becomes y to the power of 2 times 3, which is 6. Okay, again, you can pause the video and write down the notes that goes with the power rule that explains in words what the power rule says as what the distributive exponent rule says. Now let's bring simplifying exponents to another level. We're going to go into level of 3. Okay, so I asked if during class, what do you think this is equivalent to? And I wanted to get people's idea as to what they thought this was equivalent to. Okay, so we are exploring 0th power and a negative exponent. Okay, so this sort of sounds like, okay, well, actually we're going to go into looking for patterns. To explore that negative and 0 exponent, we're going to look for patterns, and I would like you to copy this table down. Okay, I did not put copy the notes here sign, but I need you to copy this table down, and we are going to be exploring it together. All right, so to fill this, let's deal with the ones that we already know for sure. Okay, probably the easiest one that we know is 2 squared. What is 2 squared? That just means 2 times 2. And that is just going to be 4. What about 2 to the power of 3? That just means 2 times 2 times 2. That is same as 2 times 2 is 4. 4 times 2 is 8. What about 2 to the power of 4 is 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? Those are the ones that we know already really easily. What does 2 to the power of 1 mean? 2 to the power of 1, just the way 2 to the power of 2 meant 2 is being multiplied to itself 2 times. This just means 2 is being multiplied to itself 1 time. So that just means 2. So this is just going to be 2. Now comes to the question, what about 2 to the power of 0? That means 2 is being multiplied to itself 0th time. How can something be multiplied to itself 0th time? That does not make sense to me. Okay, so I'm going to put a big question mark. What about 2 to the negative 1? If you use the same logic as all we've been doing, this is saying 2 to the negative 1 is 2 being multiplied to itself negative 1 times. How can a number be multiplied to itself a negative by negative number of times? So I don't know that, and I don't know this either. Okay, so to explore this, we're going to look for patterns. So let me get my pen. So we're going to look for patterns. What do you think happened to 2 to get to 4, or 4 to get to 8, and 8 to get to 16? Well, hopefully you're telling me that it's being doubled, or it's being multiplied by 2. Okay, so because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And you can actually even see it from here. Okay, whatever the previous number was, to get to 4, we just multiply by another 2. The previous number is here, and to get to the next number, we multiply by another 2 and multiply by another 2, right? So then let's try going the other direction. Okay, let's try going the opposite direction. Okay, what do you think happened to 16 to get to 8, 8 to get to 4, and 4 to get to 2? Okay, what is the opposite of multiplying by 2? It's dividing by 2. Okay, multiplication and division, they are inverse operations. Okay, they undo each other. So 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2. Then let's continue this pattern to figure out what the answer should be. So we can divide by 2. What's 2 divided by 2? 2 divided by 2 is just 1. Okay, this tells me that 2 to the power of 0 is 1. What's 1 divided by 2? So if you have one whole pizza and you're trying to share between 2 people, how many pizza are you going to get? You're going to get half a pizza. Okay, so you divide by 2. What about, let's do half. We start off with half, and let's divide by 2 again. So if you have half of a pizza and you need to share between 2 people, how much pizza are you going to get? You're going to get a quarter of a pizza. And it actually turns out how you get this number 2 here is really, this is same as 1 over 2 to the power of 1. And this number 4 here is really same as 1 over 2 to the power of 2. Because 2 squared is 4, and that's the denominator. Okay, so I do need you to copy this down, and I'm going to close this so that I can continue with the rest of the presentation. And so we know from this that 2 to the power of 0 2 to the power of 0 is going to be 1, and 2 to the negative 1 is going to be